Hello, this is a walkthrough of Mastery Exam EL, Practice Version 1, Problem 1. So this exam is all about exponents and logarithms, and this first question here is about exponent properties, very similar to one that was in Mastery Exam AA, with the additional twist that we have a cube root here. So just again to recap what the appropriate rule is for working with exponents, there are two rules to keep in mind. One says that if I have x raised to a power, say the a power, and then turn right around and raise that to the b power, I get x to the a times b power. I multiply the exponents. The other rule would say that if I have x to the a times x to the b, so I'm taking two exponent expressions and multiplying them, I add the exponents, like so. And again, the reason that's true is because why do we multiply in this situation? Well, a simple example is maybe a better explanation. For example, if I had 2 to the third power squared, why would I multiply the exponents in that case? Well, think about what this means. 2 to the third is 2 times 2 times 2, and when I square 2 to the third, that means I'm taking that 2 to the third times another 2 to the third. Like so. Now how many 2's is that? That's 6 of them, so it's 2 to the 6. I multiplied the exponents. Now by contrast, if I had 2 to the third times 2 to the second, situation where I have the same base but different exponents and they're multiplied together, what would that be? Well, that would be 2 times 2 times 2, that's 2 to the third, times 2 to the second, which is 2 times 2. And how many 2's is that? That's 5. So in this situation, I'm adding the exponents together. Okay, I'm going to box off these rules right here because they are very important. Just leave them here as references. Let's get rid of the works. I think now we have enough ammo in our holster here to solve the problem. So now let's try to work through the simplification step here. What it means by simplify completely in this context is to try to write all this expression over here on the left-hand side, the equal sign, as a single power of x to some power we don't know yet. The real problem here is to figure out what that power is. But we're simplified completely once we have this down as 1x to a single number power. So let's work in that direction here. What's helpful is to go with order of operations. We have the cube root of x squared to the fourth times x cubed. I think we need to, order of operations would tell us to do the things under the cube root sign first. And specifically this exponentiation needs to take place first. Now this, x squared to the fourth, is one of these situations where I have x to a power raised to another power. And in this case, the a is 2 and the b is 4. So that x to the second to the fourth is x to the eighth, multiplying the exponents together. And I already had an x cubed underneath there. Still keeping this cube root going along, I have x to the eighth times x to the third. That's one of these situations here where I have two powers of x and they're multiplied together, and I'm going to add the exponents there. So x to the 11th. Now I'm not fully simplified until I have x to a single power. So this is actually not, although this is mathematically correct, it would not be counted correct on the mastery exam because it's not completely simplified yet. I need to figure out x to the what power goes here. So here's where the exponent properties come in. What I have here is x to the 11th with a cube root on it. I'm going to do one extra intermediate step before we're done, and that's to write the cube root as an exponent. One of the exponent laws, I'm going to add this down here under my box, would say that if I have the nth root of x, that is a fractional exponent. So the nth root of x is the same as x to the 1 over n power. Applying that to this situation, if I have the cube root of x to the 11th power, that's the same thing as x to the 11th to the 1/3 power. A cube root becomes a 1/3 exponent. And now I'm almost done. I can just apply this top rule right here again one more time, because here I have x to a power raised to another power. I'm going to multiply the exponents, and here's my final answer. I'll put it in red so we'll know. That will be x to the 11 over 3 power. And that is my final answer. Again, this uses three different rules. One about multiplying exponents, one about adding exponents, and a third one, which we haven't seen up to this point, about taking roots and turning them into fractional exponent powers. And remember, simplifying completely doesn't just mean mathematically correct. It means mathematically correct and in the smallest form possible. So right here is where we're all happy.